Dear students, today we will be talking about surface chemistry. Surface chemistry means it's the chemistry that's related with the surface. In this chapter, we'll basically deal with the surface, the reaction that is taking place at the surface, or how the surface reacts to its surroundings. So here we basically talk about the term adsorption. Okay, so what is adsorption? The accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is termed as absorption. So that means if this is a solid, then the particles around it, okay, so it gets adsorbed at the surface of this solid particle. Now this process or this phenomena is known as adsorption. Okay, accumulation of molecular species at the surface rather than inside the bulk. This is known as adsorption. Now here there are technical terms you have to understand. The material which are on the surface is known as absorbate. So here the gas particles, if I place a stone in an open air, then the gas particle gets absorbed at the surface, right? So this gas particle is called absorbate and the stone is known as absorbent. The absorbent is a particle whose surface is used as here we can see certain examples like this powder charcoal can easily absorb the gases like oxygen, hydrogen, carbon monoxide, chlorine, ammonia or sulfur dioxide, right? Similarly, the organic dye, it contains a dye material like methylene blue. This gets easily absorbed by the charcoal. If we place a charcoal in ink, we know it, okay, or any dye substances, then all the charcoal will absorb the dye material in its surface and the solution becomes colorless. Similarly, in earlier process, okay, nowadays it is not used, raw sugar which has some color, okay, to remove that color component from the raw sugar, normally the animal charcoal was used. Similarly, we have noticed some to reduce the moisture contained in the air. Normally we see silica gel. Okay, so normally when you buy our new electronic gadgets or shoes, we see small packets, right? It's written there silica gel. Okay, its name is gel, but it's something like crystal type material is there. So it will absorb all the moisture from its surroundings such that it will protect that electronic gadgets or your shoes. Okay, so there is another it is called absorption. Earlier it was adsorption. Okay, here is the absorption. Now absorption is a bulk phenomena, right? Absorption is a bulk phenomena in which the absorbed particle gets inside the material absorbent, then it is called absorption. For example, if we have a chalk, okay, then if we put some few drops of water, what we notice is that it will go inside this chalk. Okay, it gets absorbed. Chalk will absorb the water molecule and it will go inside the chalk. So that is known as absorption. So absorption is a bulk phenomena, whereas adsorption is the surface phenomena. Here the particles which are present at the surface, it do not go inside the bulk. There is another important term, it is called sorption. Now sorption is the process where both absorption and adsorption takes place. Okay, so both this adsorption as well as absorption takes place. For example, we can take again a chalk, okay, and if we place a few drops of your ink, okay, suppose blue color ink, then what we'll notice is that the water present in a ink will get inside the chalk, whereas the dye particle gets remain at the surface of the chalk. If you break the chalk, you will notice that the color component won't be entering much deeper, it will be at the surface only, okay. So that is accumulation of the particle at the surface is the adsorption, and the going inside the bulk is known as absorption. And if both the process is taking place, then we call that process is called sorption. Now we'll discuss the mechanism of adsorption. Suppose if we take a piece of iron block, then what we notice, the iron particle which is present at the inside the bulk is attracted from all the sides, okay, all these four sides plus above and below, so it's the 6 sides, right? So they are in the state of equilibrium, whereas the particle which are present at the surface, if you notice the particle which are present at the surface, now it is attracted from the sides and it is also attracted from the below, but there is no particle above the surface, right? So we can assume that the particles which are present at the surface are in some unrest form, so they have some surface energy, whereas the bulk particles, they are equally attracted from all the sides, so they are at the equilibrium. But here there is no particle present above the surface, right? So they are in the state of unrest. Therefore, there is some unbalance or residual attractive forces for this particle. So this force of the absorbent are responsible for attracting the absorbed particle, right? So this force, unbalance force, is responsible for attracting the particle from its surroundings. So they attract this particle and they kept here at the surface. Therefore, we can say that as the surface area increases, the extent of adsorption also increases. And it has been noticed that adsorption is an exothermic process. There is one important question here, is that why adsorption is an exothermic process, right? So you have to answer like this, that during adsorption there is always a decrease in residual force of the surface, that is, there is a decrease in surface energy which appears as heat. Therefore, adsorption is an exothermic process. So what happens is that we talked about surface energy, right? So what will happen? It absorbs the surface, it absorbs the particle from the surroundings. So it decreases its surface energy. After adsorption, what will happen? It decreases its surface energy by releasing some amount of heat, right? That is why it is an exothermic process. So you cannot write simply that since it releases heat, that's why it is an exothermic process. No, you have to explain it. There is a decrease in surface energy, okay, which releases in terms of heat. Therefore, it is an exothermic process. Okay, now going to the thermodynamics, it says that delta Z is equals to delta H minus T delta S. Okay, what is delta G? Delta G is the Gibbs energy, Gibbs free energy. Delta H is the change in enthalpy. TDS, T is the temperature. Delta S is the change in entropy. Okay, so you must know the entropy, okay, by this time. What is entropy? Entropy is the degree of randomness, right? T is the absolute temperature, H is the enthalpy. Enthalpy means heat change. G is the Gibbs energy, that means amount of energy that can be utilized for work. Now looking at this process, okay, see at this diagram. So there is a box, okay, or we can say a chamber, is a closed chamber in which some gas particles are there. Now what will happen? We will put a one charcoal block here. Now as soon as charcoal block is inserted in this chamber, what will happen? It gets the gas molecules which are randomly present here, it gets adsorbed. Okay, and only the few gaseous particles are left here. So what we see is the degree of randomness has been decreased. So this is initially, then this is final, right? So degree of randomness has been decreased. Randomness of the gaseous particle. See, earlier there's lots of randomness, means they are moving randomly here and there. Now what will happen? All the particles get adsorbed at the surface. Now the particles are stick to the surface. Okay, due to adsorption, now the particle cannot move. Now the degree of randomness has been decreased. Now what will be the delta S now? So delta S means you must look at the final minus initial. So final has a lesser value as compared to initial. Okay, so degree of randomness is lesser in final. This is initial. Initial they have a high value. So lesser minus higher value. Lesser minus higher value. So this gives your negative value. Remember, lesser minus higher value, that is final minus initial value. So delta S is negative. So we have to understand that delta S is negative here. Now another important criteria is delta H. Now what will be the value of delta H? Now we have already mentioned that it is an exothermic process. Now for the exothermic process, from thermodynamics it says it is a negative. For any reaction which is exothermic, that means delta H is negative for exothermic reaction. Now T, what is T? T is the absolute temperature and it cannot be negative, so it's always positive value. Now remember, okay, now if we put this value here, so what we are getting is a negative value minus, so here is some positive value, okay, into here is your negative value, right? So we'll just multiply it. So what we are getting is a negative value minus, plus into minus means it's a negative value, again negative value, right? So now remember, what will be the delta G now, whether it is a positive or negative. Now remember, adsorption is a spontaneous process. That means it occurs on its own. We do not need any external agency to undertake this process. So we have this gas in a chamber, then we will put some charcoal block, then what will happen? The charcoal block automatically adsorbs some of the particles, right? So this is a spontaneous process. Spontaneous means that happens on its own. Now for a spontaneous process, you must remember that delta G must be negative. So it's defined, since it is an exothermic process, delta G must be negative. Now to just compare, to have a negative value out here at the left hand side, here is a negative minus negative, that means what should be there? So delta H, so only our conclusion is delta H must be more negative. It must be more negative than T delta S. Remember, to become delta G negative, our condition must be delta H must be more negative than T delta S. Now what will happen if these two values are equal? This delta H, enthalpy change, and T delta S, okay, temperature also there. T delta S is also negative. So if both the values becomes equal, then delta Z is your negative, zero. Okay, at this time delta Z becomes 0. So that is the situation, we call it equilibrium. Okay, so when T delta S is equals to delta H, then delta G becomes 0. Okay, so we can say at this stage equilibrium is attained. Equilibrium means neither adsorption takes place nor desorption takes place. Now opposite of adsorption is desorption. At desorption, what will happen? The particles will left out the surface. Okay, it will left the surface and go to the surrounding. So at delta Z equals to 0, neither adsorption takes place nor desorption takes place. The next topic is type of adsorption. So we basically discuss about two types. One is called physisorption, which is called physical adsorption. Another is called chemisorption, or we call it chemical adsorption. So here physics options means it's a basically we talk about accumulation of gas on a solid particles, right? So this comes under the topic physics option, where the force of attraction between this particle and this absorbent and absorbate, okay, is van der Waals forces normally. But here chemistry option means A plus B, two reactants react together, they come together, okay, and react to form C and D. So they are coming together, A and B are coming to each other, okay, and they are in contact with each other, then they react. So that process we basically describe in the term of chemistry option to give the product C and D, whereas physics option is the accumulation of gas on the solid. There is one important differential comparison of physics option and chemistry option given in your book, page number 126. Here, these are important, okay? So it arises. So physics option arises because of the van der Waals force. So chemistry option is basically the chemical bond. Physics option is not specific in nature. So that means a particle can attract its surroundings, a particle from the surrounding. It's not specific that this molecule will get attached, other will not attach. So it can attract anyone from its surrounding. It's not specific, but its chemistry option is highly specific. That means A reacts with B, A doesn't react with C, okay, so it's highly specific. It's a reversible, so we can reverse, okay. So that is basically we discuss in the terms of desorption. If we decrease the pressure, then the adsorption decreases. So in this way we can achieve this desorption. Here it's a irreversible, so A reacts with B to form C and D, right? So C and D doesn't react to give A and B, so it's irreversible. Here it depends on the nature of the gas. Easily liquefiable gas are readily absorbed, okay. So though it's not specific, but it says that okay, the few are preferable. The gases which are readily liquefiable, okay, they are readily absorbed. Easily liquefiable, they are readily absorbed. Whereas it also depends on the nature of the gas which can react with the absorption source chemistry, okay. So there is a reaction, so there must be a reaction between A and B, that is gas and the particle, then only the chemistry option takes place. Here the enthalpy, that is we talk about okay, this one adsorption is an exothermic process, but the heat release exothermic process, the heat release is very low, it's 20 to 40 kilojoule per mole, whereas in case of chemistry option it's very high, it's 82 to 40 kilojoule per mole. Other comparisons include that low temperature is favorable for physics option, whereas high temperature is favorable for chemistry option, okay. No appreciable activation energy is needed, and here we know for a reaction we need to have very high activation energy. It depends on the surface area, it also depends on the surface area. It results in the multi-molecular layer. So one layer is present, absorption, then another layer may be present, okay. It results in a unimolecular. So A reacts with B, okay. Done. So it's basically unimolecular. There is no question of multi-molecular layers, right?